in suitable quantity of water and dilute into 50 ml volumetric flask by using water up to the mark. That is, after dilution, we come to the point, the prepared solution is 0.1 normal oxalic acid solution. And what is the, in simple form definition, the solution of known concentration is known as standard solution. See here we, in picture, we show different types of volumetric flasks from 50 ml to 250 ml. By using different solutions or different solute materials, we comes to the final conclusion, it is particular normal solution. After this, we go to the next point, that is titrant and titrant. What is titrant and what is titrant? See here, in analytical chemistry, titrant is a solution of known concentration. Titrant is a solution of known concentration. The solution we prepare by using solute, solvent and volumetric flask. The solution we prepare by using particular solute, then particular solvent and volumetric flask. They have known concentration. What is important in titrant? The titrant is a solution of known concentration that is added or titrated, to the another solution, to determine the concentration of second chemical species of the analyte or titrant. What I tell, now we see, focus on picture. See here, in this picture, here is one burette, here is a beaker. On burette, the solution filled is from volumetric flask. That is, the solution of known concentration are placed in this burette, and hence it is called as titrant. Solution of known concentration is called as titrant. And in this beaker, we take one reactant. Suppose, imagine in the burette, here is presence of 0.1 normal HCl solution. And in beaker, there is presence of 0.1 normal NaOH solution. Then NaOH solution is a titrant. What we titrated in this solution? The normality of, we prepare 0.1 normal HCl, having exact normality 0.1, and by using this HCl, we determine the normality of this NaOH, and hence the solution of known concentration is a titrant. But the whatever may be the solution, we want to determine the normality of this. This is a titrant. This is called as titrant or analyte. In picture, we imagine very simply the solution of known concentration we fill in burette. It is titrant, and solution of unknown concentration we take in conical flask or a beaker. It is titrant or analyte. Then after this, we go to the next point, that is mole. What is mole? The amount of substance. See definition: the amount of substance whose weight in grams. Amount of substance whose weight in grams is numerically equal to its molecular weight. Of substance. Amount of substance whose weight in grams is numerically equal to its molecular weight of substance is known as 1 gram molecule or 1 mole of substance. What is in simple? The amount of substance whose weight in grams, is numerically equal to its molecular weight, of substance is known as 1 mole of substance. Now we comes to the point molar solution. A solution containing 1 mole of substance in 1 liter. What is mole? Mole means whose weight is exactly or numerically equal to its molecular weight. Now we comes to molar solution. A solution containing 1 mole of substance in 1 liter. Suppose we want to prepare 1 molar NaOH solution. What is the definition? a solution containing 1 mole of substance in 1 liter. That is, our final volume is 1000 ml. 1000 ml. Then, what is here quantity? Here is question mark. We want to prepare 1 molar solution of NaOH. How much amount of NaOH we dissolve
One mole.
in particular water? Tell me.
One more.
1 mole. 1 mole, sir.
What is he writing here? The amount of substance whose weight in grams is numerically equal to its molecular weight. That is, in 1 mole, we take a reference as its molecular weight. What is? If we want to prepare a 1 molar solution of NaOH, then how much grams NaOH we want to take? किती घ्यावं लागेल NaOH? What is molecular weight of NaOH? What is molecular weight of NaOH? बरोबर आहे, बोला किती आहे?
40 gram per mole.
How many? Molecular weight of sodium is 23, oxygen is 16, and hydrogen is 1. If we want to prepare a 1 molar solution of NaOH, then we must dissolve
4 gram.
not 4, 40.
40 gram. Sorry.
40 gram of NaOH in 1000 ml of water or suitable solvent, then it forms 1 molar solution of NaOH. Now we go to next definition, that is molarity of solution. Number of moles of solute per liter of solution. Number of moles of solute per liter of solution. Here we take different types of solute. The solution we want to prepare, if we want to prepare NaOH solution, then solute is NaOH. HCl, then solute is HCl. KOH, then solute is KOH. The number of moles of solute per liter of solution. Here I explain one example. Calculation of molarity. See here what I write, or what is the example. This type of examples are always asked in competitive exam, like entrance exam in MSc, taking admission for MSc. See here, what is the molarity of solution made by, see, listen carefully question. What is the molarity of solution made by dissolving 2.5 gram of NaCl enough water to make 125 ml of water or 125 ml of solution? What is the formula of molarity? Number of moles of solute. Number of moles of solute. See here in definition also. Number of moles of solute per liter of solution. Per liter of solution. But how calculate? If in problem they use a weight in gram of particular solute, then how we calculate moles? See here, what is the definition? Number of moles of solute per liter of solution. Then how we calculate number of moles? How much quantity they give in problem? 2.5 gram. Weight in gram, 2.5 gram. Weight in gram divided by its molecular weight. What is the molecular weight of NaCl? Sodium 23 and chlorine 35.5. Total count is 58.5. Again I repeat this. How we calculate number of moles. For calculation of number of moles, formula is weight in grams given in problem, weight in grams divided by its molecular weight. Weight in grams in problem, they give 2.5 gram of NaCl and molecular weight of NaCl is 58.5. After dividing this, we get answer like this, 0.0427 mole. Then from the given value, we calculate number of moles of NaCl present in solution. Now we place the value in formula. Molarity is equal to number of moles. Number of moles of solute. Solute is NaCl. Number of moles 0.0427 divided by liter of solution. They give 125 ml. If we convert this 125 ml into liter, then it must be 0.125 liter. And after calculating this, the molarity of particular NaCl solution is 0.34 molar. This type of questions always asked in entrance examination for taking admission in MSc. Now we focus on another terms regarding gram equivalent weight. It is a weight. It is a weight of substance. See here what I write. It is a weight of substance in grams. Weight of substance in grams, which is chemically equivalent to which is chemically equivalent to 1 gram atom of hydrogen. It is weight of substance in grams, which is chemically equivalent to 1 gram weight of hydrogen. Don't focus on this. We focus on normal solution. Use of gram equivalent weight in normal solution. What is normal? A solution made by dissolving 1 gram equivalent weight of substance in sufficient distilled water to make 1 liter of solution. Now here is one question. Up to this stage, all of you use different normal solution in laboratory like 0.1 normal NaOH, 0.1 normal NaOH to 1 normal NaOH or different dilutions. Now, what is the definition? A solution made by dissolving 1 gram equivalent weight of substance in sufficient water to make 1 liter of solution. To make 1 liter of solution. If we want to prepare not 0.1, 1 normal NaOH, 1 normal NaOH. In how much quantity? 1000 ml quantity. What is the weight taken for it?
40 gram.
Why 40 gram? The answer is correct and very good, but why 40 gram? Because before this, we study molarity. Molarity is nothing but its molecular weight dissolved in 1000 ml, and hence we dissolve 40 gram of NaOH in 1000 ml of water. But here our next term is normal. Answer is correct, 40 gram of NaOH in 1000 ml. But how we take 40 gram of NaOH? Or why we take 40 gram of NaOH? Anyone from boys and girls? Tell anything about the normality. I not expect correct answer, but I want answer. It may be correct or wrong. And I want answer from boys. Hello, am I audible?
Yes, sir.
Okay. Okay. See, I explain what is gram equivalent weight in calculation point of view. You take equivalent weight. What is the formula? Equivalent weight is equal to molecular weight divided by acidity or basicity. This is the formula. Acidity or basicity. What I write here, a solution made by dissolving 1 gram equivalent. What is the formula of equivalent weight? Equivalent weight is equal to molecular weight divided by acidity or basicity. If we calculate the equivalent weight of acid, then take molecular weight by basicity, and if we calculate normality of base, then take molecular weight divided by acidity. For base, take acidity. For acid, take basicity. Here, our example is NaOH. NaOH is acid or base? NaOH is acid or base?
Base.
Basic.
Base.
Base.
Base. Very. What is the formula? Molecular weight. What is the molecular weight of NaOH? 40.
40.
Divided by, if we take base, then divide it by acidity. How much amount of H plus ion required to remove this OH minus? किती H plus लागतील आपल्याला ते OH minus घालवून टाकण्यासाठी किंवा OH minus न्यूट्रलाइज करण्यासाठी किती H plus लागतील आपल्याला?
1.
1. And hence if we divide this one, then again 40. Molecular weight is 40 divided by, here we take base and divided by acidity. For replacement or for neutralization of this OH minus, we require 1 H plus and hence we divide here 1. As molecular weight and equivalent weight is same in NaOH, that is 40, and hence if we dissolve 40 gram of NaOH in 1000 ml of water, then there is formation of one normal solution of NaOH. It is also called as 1 molar solution of NaOH because acidity is 1 in both cases. See here normality. The normality of solution is the gram equivalent weight of solute. Here we take NaOH as a solute per liter of solution. Solute per liter of solution. It may be called as equivalent concentration. That is, normality is also called as equivalent concentration. See now next slide. Up to this stage, we define different terms like normality, molarity, mole. Now we differentiate these two forms. Normality is also called as equivalence concentration. It is known as molar concentration. It is defined as the number of gram equivalent per liter of solution. Here we take moles. For moles, we take molecular weight. It is used in measuring the gram equivalent in relation to the total volume of solution. It is very simple. That is the gram equivalent weight dissolved in particular volume of solution. It is used in measuring the ratio between number of moles in total volume of solution. Here we take number of moles. Here I explain units for normality, normal or equivalent liter, equivalence liter inverse, molar, that is capital M, or moles per liter, equivalence per liter or moles per liter. These are simple differentiation. Then neutralization. What is neutralization? When an acid and base, when an acid and base react, the reaction is called neutralization. Here I take one basic molecule, here I take again acidic molecule. There is formation of this OH and this H to form this water molecule, H2O, and Na and Cl to form this salt, NaCl. This is called as neutralization. See or remember practical course in SYBSE, if you do titration like titration of 0.1 normal NaOH and 0.1 normal HCl, then at the last stage, if examiner or your teacher tell you pipette out 25 ml of 0.1 normal NaOH by using phenolphthalein as the indicator and titrate against 0.1 normal HCl, then result of reading must be near to 25. That is, your reading comes from 24 to 26. Why this happens? Because if we take 25 ml of 0.1 normal NaOH or HCl, then for neutralization of OH minus, the requirement of 1 H plus. 1 OH minus replaced by H plus and finally comes to water molecule. If there is 25 moles or 25 OH minus, then it must require 25 H plus. And hence reading, because of some personal errors, some technical errors, your reading starts from 24 to 26. But if anyone shows reading 30, then it is out of range. It is totally wrong, and examiner does not give marks to this type of titration, because personal error we start from 0.5 plus minus, but here I explain plus minus 1. It is also okay. Then we focus on definition of titration, the process of determining the quantity of analyte. What I tell, the process of determining the quantity of analyte by measuring the volume of standard solution that is required to complete the reaction with analyte. Again, I tell simple definition. Again, see same example. In burette, there is a solution of known concentration, and in second slide, we call it as a titrant. It is titrant. And whatever may be the volume for chemical kinetics, you take different types of solution in 2 ml, 3 ml, 5 ml, to it add ice, and finally titrate with burette. What is present in this conical flasks? It is analyte. It is analyte. What we want to calculate, the value, or what we want to calculate, the concentration or quantity. Here in chemical kinetics, we give different types of solutions, and this analyte is also called as in second slide. What we call analyte? Analyte is also called as. Tell me. Analyte is also called as
Titrant.
titrant. Yes, very good. Titrant is present in burette because we know its original concentration, and we calculate by using this titrant what is the titrant or what is the analyte present in given solution. It is a titration. Then again in our syllabus there are acidometric titration, alkalimetric titration. What is acidometric? When standard acid solution is used for quantitative determination of alkali. That is what is in simple. When acid is present in burette, then this is acidometric titration. Because in burette we always feel the solution of known concentration. When standard acid solution is used for quantitative determination of alkali, then this is called as acidometric. When alkali is taken in burette, that is solution of known concentration, then this is called as alkalimetric titration. When standard alkali solution is used, then it is quantitative determination of acid, then it is alkalimetric titration. Now we focus on indicators. In picture, I show different types of indicator from methyl orange, bromophenol blue, thiol blue, phenolphthalein, alizarin. Some indicators are new. I think you familiar with only phenolphthalein and methyl orange. Only these two indicators you use up to SYBSC. I see what types of colors. See, we focus on phenolphthalein. Phenolphthalein in pink is pink in color in base, is colorless in acid. That is depending upon analyte or depending upon the person who carry experiment in laboratory. If the person added the particular indicator, that is phenolphthalein in acid, then endpoint is pink to colorless. But if the analyst add the phenolphthalein in base, then endpoint is pink to colorless. These are this chart showing different types of colors found shown by indicator in different types of solution. And here also I explain pH ranges. Depending upon pH, we select the indicators. In simple, what is the indicator? Indicators indicates color change of completion of reaction. What is the definition? A chemical substance that changes the color in accordance with the pH. Changes the color in accordance with pH is the most important condition in indicator. The chemical substance that changes the color in accordance with pH of solution, and thereby we determine the end point of titration. By using this, we come to the point end point of titration. This is indicator. Indicator indicates color change in accordance with pH. Then after we see what is equivalence point and what is end point. Point in a titration at which amount of titrant added is just enough to completely neutralize the analyte. Just enough. That is, go to flashback in SYBSC. If you carry the titration of NaOH and HCl and by using phenolphthalein indicator, or if you carry out the experiment of chemical kinetics in physical chemistry laboratory, at some point you reach to the point after placing one drop of titrant, the conical flask shows pink color. But before this addition of one drop from burette of known concentration, that is titrant, the solution is colorless. And this point before pink color is called as equivalence point, or before indicator color is called as equivalence point. The point in titration at which the amount of titrant added is just enough to completely neutralize the analyte solution. Just enough. After one point, after one drop, the conical or the reaction hue or indicator shows color indications. Or what is the end point? The point at which titration is complete, usually marked by change in color of indicator. Only one drop difference between endpoint and equivalence point. Before observation of color it is equivalence point, but after color formation it is endpoint, point where indicator changes the color. The point at which titrant is chemically equivalent to analyte. Titrant is chemically equivalent to analyte in the sample. That is it is neutralization point. Comes after equivalence point, comes before equivalence point, then after endpoint. Weak acids have only endpoint. See here, weak acids have only endpoint. Weak acids can have multiple equivalence point. Weak acids have multiple equivalence point, and the difference between endpoint and equivalence point is called as endpoint error. What I tell, it is also asked for bits or multiple choice questions. The difference between endpoint and equivalence point is called as endpoint error. Now, in third or fourth slide, I tell we use oxalic acid as a primary standard for standardization of different solution like NaOH, KOH, different bases. Then what is primary standard? In oral exam of practical, the examiner always ask if your titration containing oxalic acid, what is the role of oxalic acid? Why you use oxalic acid? What is primary standard? What is secondary standard? What are the characteristics of primary standard? In the primary standard, I explain all these things. Primary standard are those chemical reagents, having high percentage of purity, high stability towards air, high molecular mass, radially soluble in the all solvents, having medium cost and readily available. See here, high purity, stability, low hygroscopicity. That is, it must not hygroscopic because it is humidity sensitive. See here, to minimize the weight changes due to humidity. If you take talcum powder, it is hygroscopic in nature and placed in open atmosphere. After some time, it is somewhat humid in nature. If you see a milk powder also, milk powder in home, all student does not see milk powder, but if milk powders we place in open climate, then after 10 or 15 minutes it's humid, and there is changes in weight. High end point, non-toxicity, readily and cheap available. All conditions are must or asked in exam also. Here I explain few primary standard materials. See here, potassium hydrogen thalate used as a primary standard for standardization of NaOH. Here in our laboratory we use oxalic acid. The formula is can you tell formula of oxalic acid? It is a dibasic acid, COOH, and here we take twice H2O. Molecular weight is 126, and for making one normal solution we take 63. It is my question, how to prepare one normal solution of oxalic acid for next lecture. Sodium carbonate is used as a primary standard for standardization of HCl. Disodium oxalate, Na2C2O4 is the disodium oxalate is used as a primary standard for standardization of KMnO4. Potassium permanganate, zinc pellets or magnesium ribbons are also used as a primary standard for standardization of ethylene diamine tetraacetic acids. These are some materials regarding primary standard. Try to see or try to make note on primary standard. It is very important. Titration exponent, the pH at which titration in the presence of a given indicator is ended. The pH at which titration in the presence of given indicator is ended is called as titration exponent. And this is my last point regarding this lecture, but I want some questions from all of you. Now session is open for discussion. Please ask different questions for understanding this lecture. Anyone regarding any type of queries, please ask me. Anyone have queries? I think I want the question for to Anjali Mahadik. Anjali Mahadik. Unmute itself. Unmute करा तुम्हाला अंजली महाडिक.
Yes, sir.
You understand all the concept regarding today's lecture?
काही समजलेत.
You understand or not understand?
Understand.
Any query regarding this lecture?
नाही.
गौरव चव्हाण अनम्यूट करा प्लीज. गौरव चव्हाण. Make attention on your lecture. If you listen the lecture, don't in sleepy mode. Am I audible to all?
Yes, sir.
Okay. प्रतीक्षा कदम काय क्वेश्चन आहेत का?
नाही.
Okay, now I explain last slide or of today's lecture. See here, theory of. Are you see the screen? Screen दिसते का screen?
नाही दिसत आहे, सर.
Okay, wait. This is our last point in today's lecture. Theory of titrimetric analysis containing color change interval of indicators. I think now screen is visible. Screen दिसते ना?
हो.
Okay. Color change interval of indicators. The color of neutralization indicators changes in definite narrow range of pH. That is, here we select, depending upon selected titration, wide variety of indicators depending upon their pH ranges. See what type of points. For good result of volumetric, that is titrimetric analysis, reaction must fulfill following conditions. Here 1, 2, 3, 4, 5, 6, 7. Here I explain 7 conditions. These questions, good conditions for titrimetric analysis, are asked in exam for 2 marks or short note. For good result in volumetric or titrimetric analysis, reaction must fulfill following conditions. Reaction may proceed with greater speed. Practically, what I write? Reaction may proceed with greater speed practically or made by using suitable catalyst. The catalyst is very important word regarding this slide or reaction. The catalyst lowers the energy of activation and increases the rate of reactions, and hence reaction must proceed with greater speed practically or made by using suitable catalyst. If reaction is very slow, then you have choice to use different types of catalyst to increase the rate of reaction. Then next point is reaction may proceed quantitatively with equilibrium constant. That is, we see equivalence point and end point. The reaction must proceed quantitatively with equilibrium constant. It has specific equilibrium constant. Reaction must be simple and expressed in chemical equation. Reaction must be simple and expressed in chemical equation. Any side reaction must not occur. See what I write here, any side reaction must not occur. If we want to titrate NaOH with HCl, there is a formation of NaCl and water. NaCl is a salt and it's soluble in water. That is, there is no side reaction or no side product. But at the same time, reaction of NaCl and reaction of NaOH and HCl, if there is formation of another product which does not soluble in particular neutralized water or form water, then this is side product. And hence, for good titration or good volumetric reaction, the side reaction must not occur. The analyte must react completely with titrant. That is, this, whatever may be the solution taken in a burette, the solution or the titrant or analyte must react completely with burette solution or titrant. At equivalence point, there must be appreciable change in free energy to alter the physical and chemical properties of solution. That is, if we reach to the equivalence point, reaction must complete, and that is like a neutralization point. And last point is, indicator with suitable pH ranges should be available. For particular titration, phenol, for particular, that is, here we take example like NaOH and HCl, titration of NaOH versus HCl, there not must be presence of phenolphthalein. You select the titration, you select the reaction in the form of, there have wide variety of choices of indicators, not only phenolphthalein, not only methyl orange. You choose the titration or you choose the indicator, apply in variety of titrations. These are some basic regarding this unit. In next lecture, actually our syllabus, main syllabus starts from the color change intervals of indicators, and all previous things are asked in different types of competitive exams. You must familiar with this type of concepts: normality, molarity, molality, standard solution, titrant. These all things are most important in practical session also. Then what is primary standard, what is secondary standard, what what are the characters for primary standard? These are important regarding the analytical chemistry. I think I touch the lot of basic points regarding this lecture. Okay, we stop here. If anyone have queries regarding this lecture, you have choice to tell me. Anyone have queries? Okay, we stop here.